So, hi, this is Team 19, and we are here to present our project about loss ratio prediction. This project is basically about developing a predictive model to predict the loss ratio for different portfolios of an insurance company. So, these are our teammates, myself, Vignesh Ramsetti, Shrita Cherikuri, and Shushma Sakineti, and Indu. So, coming to our agenda of this presentation, I will start with a small introduction about this project and continue to the EDA, data exploration, pre-processing, modeling, and end this meeting with the findings we got from this project and the predictive models. So, coming to the introduction, there are thousands of insurance companies in United States with a huge amount of data stored with respect to policies, customer details, and so on. This provided data set is of an insurance domain, which is related to automobile insurance policies. As per the project description given by the professor, the insurance domain encounters difficulties in correctly placing the insurance prices for the policies because 10% or more of the policies have pricing deviations in about 50% of the cases. So this problem statement gives a clear need for designing a model which helps in determining the loss ratio of insurance policies and help the company in correct pricing of the policies like decreasing or increasing according to different attributes. So it is very important for insurance companies to understand the data properly to get these results. So coming to the EDA, it's like, sorry, the objective. As I said earlier, the objective of this project is to develop a predictive model to predict the loss ratio function. The model that we develop should have high accuracy and less mean square error, which means the best model we can come up with. So the formula we use it for this natural log of loss ratio is given below, that is ln of total losses by total premium. These two attributes are given in the training data by the professor. So moving on. So these are some of the data visualizations we generated to get a better understanding about this data. So the first screenshot shows you the bar chart that shows how many 6 month plans and how many 12 months tenure insurance policies are there in the training data set. And the second one shows you how many prepaid and how many installment wise paid insurance are there. And the third one is a scatter plot for between annual premium and the claim count. The fourth one is a box plot to to find out the outliers for annual premium. The fifth one is like a heat map for correlation, which gives the correlation between every attribute with the other attribute in the training dataset. And the sixth one shows a scatter plot between annual premium and vehicle data driver points. So moving on to the next slide. So data exploration is also one of the main part of this project. As you can see, this includes exploring the data and getting to know better getting to know better knowledge about this data. So as you can see, there are almost 69 columns, that is 69 different attributes in this training data set that is provided by the professor. So next slide. So data exploration includes data visualization, data understanding, and getting a data analysis as well. So descriptive statistics such as finding mean, correlation, standard deviation are used to help us to get better and deeper understanding about the data, which will help us in future to develop a good predictive model. Using different types of data visualization techniques is also important to get visual understanding about various attributes of the data. So this concludes data exploration, and data preparation include like loading the data, data cleaning, and other concepts. So moving on. So the process of developing a predictive model is this, and this will be explained by Ashrita. Yeah, Ashrita, take over.
Yes, the flow of the project starts with the data cleaning and then feature selection, then to train the model with the selected features and select the best model that fits the training best for the given training data, and then we test the model and get the predictive values for as the output. Starting with the data preparation or the data cleaning. So in the given data set, which is a huge data, so we have first started with the sorting out the data set with the data that we need for the to train the model. So the unwanted data or the missing data, we have dropped the data and we scale the data with the necessary attributes. And next step is so here the feature selection. The important part of this project is based on this feature selection. And this feature selection is done with the uh, so we have selected this features if they have 80% of the missing values, or we have removed that one, or we found the correlation like we have showed in the EDA examples. So based on these factors, we have selected the features, and we have continued the prediction. So the models we have that we selected is as follows: that KNN, random forest, and linear regression. All the three models have given good values for the given data set, but we have chosen the best one, best among them. So the linear regression, which have so here we have mainly concentrated on mean absolute error. So we can even try with the mean squared error or to score, but since we have got the uh, huge difference and accuracy with good accuracy at the end, so we have limited by checking with the mean absolute error, and it is one of the option, but we can even try later with the mean square error, and then select the best model. So here with the linear regression, we have got around 3,60,000, and with the random forest, we have a very good mean accuracy error. So since the mean accuracy error should be less for a model to get the good prediction, uh, among the three, we got random forest as the best model. So using the random forest, so we have selected the random forest as our predictive model, and then we followed the following method. So here we have used we have created the portfolios for the training data set, like we have for the testing data set for the convenience, and then for the created portfolios, we have found the mean absolute error, and have formed a new for the new data set. And uh, here I need to mention that the portfolios for the training data set are done based on the categorical values and numerical values. So from the given data set, we found the categorical values, and then we made a new data set and formed the new portfolios. For the new portfolios, we found the mean absolute error, and trained the model. And for the selected model, that is in our case, it is random forest. We have found the loss ratio and natural logarithm for the testing data set, and then we submitted our results into the Kaggle leaderboard. So here is an example of the testing model. So the testing data set have around 400 600 portfolios, and Uh,
31
and
portfolio.
this is the findings that we have found that, as I mentioned earlier, that random forests have given a good value prediction for our data set, and we have got the good accuracy with the random forest model for the given data set. And yeah, that's it. Thank you for this. And just a quick walk through the code. Vignesh, can you skip to the other slide? So this is a quick walkthrough through the code. So here the data that we have selected, and few visualizations part, and so as I mentioned that we have created the portfolios based on the categorical value, variable and numerical variable. So here is a function that exactly gives us what categorical values and numerical values for the data set. And these are the features that we used, and uh, creating the data set of using the categorical value uh, and numerical value. And then this is the next step for preparing the data set, training data set. Yeah, a few updates on that, making it more scaled for training the data set. And here are a few values that would give us a clear idea on which one would be the best one, and the selected features, the sorted selected features for the new training data. Yeah, here are the models. So we have mentioned three, but we have tried few more, like decision tree and all, but that it does not it did not give a good result. So we haven't uh, noticed gave important that much. And here is a step for loading the test portfolios. And then we have then used the categorical and numerical values of even the for the testing data set. And as I mentioned, so previously the testing
Me
data
31,
set is around 400 to 600. So here we have the 600 portfolios.
300.
And sorry.
Me 31 portfolios.
And here is the generated value, uh, CSV.